Hello, welcome friends in the EVCOM series of the GTU. Today I am going to continue with the chapter number 4, that is the properties of the steam. In the previous lecture we have completed the difference between gas and vapor, formation of steam, types of steam, specific enthalpy and specific volume of steam. In the today's lecture we are going to review the fundamental of the formation of steam along with the type of steam, specific enthalpy and specific volume of steam, and we will solve some numericals based on the specific enthalpy and specific volume of steam. Now, reviewing the fundamental of formation of steam, as we have studied in the previous lecture, let us consider a frictionless piston and cylinder assembly in which 1 kilogram of water is filled up at 0 degree centigrade and standard 1 atmospheric pressure is acting on it. At that pressure, the boiling point or saturation temperature of water is 100 degree centigrade, and that condition is known as state A. Now, as we want to generate the steam, we have to heat the water at state A. So, when we are heating it, the temperature of water continuously increases and it increases up to the saturation temperature, that is the 100 degree Celsius temperature, and the point number B or state B is reached. That kind of condition is known as the saturated liquid. Now onwards, actual formation of steam starts, and when we start heating again, some of the water is converted into steam and some of the water remains in liquid condition, and that condition is known as the wet steam. At that point, the temperature of steam is 100 degree centigrade, that is the saturation temperature, and at the state C we get the mixture of liquid and evaporated liquid, that is the wet steam. Yet we want to convert the 100% water into the 100% steam, and therefore when we supply the heat again, the state D is reached where 100% water is converted into steam, and that steam is known as the dry steam, and at that point D also the temperature of steam is the saturation temperature, that is 100 degree Celsius. Again, if we continue to heat the steam at point D, we reach the at state E, and the temperature of steam increases more than the saturation temperature, and that condition of steam is known as the superheated steam. So friends, that we have studied all these steps of the formation of steam in the previous lecture, and today we are going to just review that temperature and specific enthalpy diagram for the formation of steam. At state A, the temperature of water is 0 degree Celsius, so it is located at the origin. When it is heated up to the state B, the temperature of the saturated liquid is saturation temperature, so we get the line AB on the temperature enthalpy diagram. Continuing on the heating, we get the point C or state C where we get the wet steam having the mixture of water as well as the steam. Again continuing it, we get the point D where the dry steam is obtained, and again heating we get the point E where it is known as the superheated steam, and this is the combined diagram of the formation of steam. Now, reviewing the equations utilized for calculating the properties of steam at different points, that is point number B, point C, D and E. So, at state B, the condition is saturated water, temperature at point B is T sat. Specific enthalpy at point B, it is given by the equation HF is equals to Cp of water multiplied by Tb minus Ta, that is temperature at point B minus temperature at point A, kilojoule per kg, and specific volume of steam is Vf meter cube per kg. So, as we have studied in the previous lecture, the values like T set, HF and VF can be obtained using the steam table. So if we want to find out the properties at point B, we have to use the steam table at particular pressure. The properties at C. The type of steam is known as the wet steam. Temperature at point C is T set. Specific enthalpy of steam is known as H wet, and the equation is HF plus X multiplied by HFG kilojoule per kg, and specific enthalpy, specific volume for the wet steam is V wet, that is equals to X multiplied by Vg. Now all the values like T set, HF and HFG and Vg we will get from the steam table. Only the value X it is required. So here, depending upon the numerical, sometimes dryness fraction X is given in the numerical and we have to find out H wet. Sometimes H wet is given and we have to calculate the X, where X is the dryness fraction and it can be calculated using the equation mass of dry steam divided by mass of dry steam plus mass of water. Properties at state D. The condition of steam at state D is known as the dry steam, or it is known as the dry saturated steam. Temperature at point D is T set. Specific enthalpy at state D is H dry, specific enthalpy of dry and saturated steam, that is equals to HF plus HFG, or that is equals to Hg kilojoule per kg, and specific volume of dry steam, that is V dry, that is equals to Vg meter cube per kg. Friends, the values like T set, HF, HFG and Vg is also available from steam table. So the properties at state D can be calculated using the steam table. The properties at state E. The type of steam is known as the superheated steam. Temperature at point E is greater than T set, so it is known as T sub, superheated temperature. Specific enthalpy of steam H sub, that is equals to HF plus HFG plus Cp of steam multiplied by T sub minus T set kilojoule per kg, and specific volume of steam, that is V sub, is equals to Vg multiplied by T sub divided by T set. Now in this, as the temperature of steam is more than saturation temperature, here also in numericals sometimes superheated temperature is given, so we can use it, which is more than the saturation temperature, and sometime we have to calculate or we have to find out the superheated temperature, that is T sub, from the data given. In the specific enthalpy, CPS is the specific heat of steam, and the value is constant, it is constant, and its value is 2.1 kilojoule per kg Kelvin. Other values like HF, HFG and T set is available in the steam table. And one important fact that you should remember is, for calculating the V sub, you have to substitute the value of T sub and T set in Kelvin only. Then and then the correct answer is obtained. Now let us see just how the steam table is. So the steam table, one is a pressure based steam table. It has the first column is pressure and rest columns are saturated temperature, that is T set, specific enthalpy HF, HFG and Hg, and specific volume Vf and Vg. So if we know the pressure, that is anyone, right, so we can calculate or we can find out the other values like T set, HF, HFG, Hg, Vf and Vg. So this is one kind of steam table which is known as the pressure based steam table. The another kind of the steam table is temperature based steam table, in which the first column is T set, and if we know the saturation temperature, we can find out or we can take the other values like absolute pressure, specific enthalpy and specific volume. Friends, most generally, or you can say most commonly, we are going to use pressure based table only. Sometimes, or you can say at one or two places only, we have to use the temperature based steam table. Now we will solve the problem based on the specific enthalpy and specific volume of steam. Calculate the enthalpy of 8 kg of 90% dry steam at an absolute pressure of 12 bar. Now the important thing in solving any problem is that we have to read the problem 2 times and extract the correct data from the numerical, and then it will be easy for us to find out the correct solution. So again we will read the question and extract the correct data. Calculate the enthalpy of 8 kg. So they have given us first data, that is 8 kg. So 8 kg is mass of steam is equals to 8 kg. Second is 8 kg of 90% dry steam. It means they have told us that the steam is 90% dry and 10% liquid. So we can say that 90% the data they have given is dryness fraction. So x is equals to 90%, that is equals to 0.9. Then at an absolute pressure of 12 bar, it means they have told us that pressure of steam is 12 bar. So that is the correct extraction of data from the numerical that they have given us. And what we have to do? We have to calculate the enthalpy. Now as we have studied in the formation of steam or the steps for the steam generation, we know that there are many types of steams, or there are many stages, like it may be saturated liquid, it may be wet steam, it may be dry steam, or it may be superheated steam, and the enthalpy equation for all 4 states are different. So first of all, or the first step is to identify the type of steam, and then we have to use the equation. So from the data given, as we know that they have given us dryness fraction, that is x is equals to 0.9. It means it is the wet steam. So they have given us the wet steam, and for wet steam the equation for the enthalpy is H wet, that is equals to HF plus x into HFG kilojoule per kg. So now using this equation we have to calculate the specific enthalpy of wet steam. Now to solve this equation we require the values of HF, X and HFG. Now from the problem we know that they have given us X value, that is 0.9, and we require other 2 values, that is HF and HFG, and that is obtained from the steam table at the given pressure of steam. So we have to look at the steam table and we have to find out the data from the steam table at 12 bar pressure. So from steam table at 12 bar pressure, HF value is 798.4 kilojoule per kg and HFG is equals to 1984.3 kilojoule per kg. Now substituting all 3 values in the enthalpy of wet steam equation, so H wet is equals to 798.4 plus 0.9 multiplied by 1984.3, that comes out to be 2584.27 kilojoule per kg of steam. Now friends, we have got the answer, that is specific enthalpy of wet steam, that is equals to 2584.27 kilojoule per kilogram of steam. It means it is only for 1 kilogram of steam, and in the numerical they have asked us that we have to find out, or we have to calculate the enthalpy of 8 kilogram of steam. It means we have to find out the enthalpy of 8 kilogram of wet steam. So capital H wet, that is equals to mass of steam multiplied by specific enthalpy of wet steam. Now mass of steam is 8 kilogram and specific enthalpy of wet steam is 2584.27. Substituting this value, so capital H wet, that is total enthalpy of 8 kilogram of wet steam, that is equals to 8 multiplied by 2584.27, which comes out to be 20,674.16. So this in this way we have got the answer for this numerical, in which the wet steam is given having the dryness fraction 90%. Let us study the next numerical for the specific enthalpy. Calculate the enthalpy of 10 kilogram of dry and saturated steam at a pressure of 15 bar. Again we will read the problem and find out the or extract the correct data. Calculate the enthalpy of 10 kilogram. It means the mass of steam is 10 kilogram of dry and saturated steam. So in this problem they have clearly mentioned that the steam is dry and saturated steam. So next data or important data is dry and saturated steam at a pressure of 15 bar. It means they have given us pressure of steam is equals to 15 bar. Now in this problem also we have to calculate the enthalpy, and here out of 4 possible ways, that is the saturated liquid, wet steam, dry steam and superheated steam, they have already given us clearly that steam is dry and saturated steam. It means, and for the dry and saturated steam, H dry is equals to HF plus HFG, that is equals to Hg. Using this equation we can calculate the enthalpy or specific enthalpy of dry steam. Now in this equation we require values of HF and HFG, or we require the value of Hg.